what that would mean is I'm going to plug 1 in for k, right? But there isn't a k, so that would just mean I'd have 1. And then when I plug 2 in, well, there's no place to put it, so it should be another 1. And I put 3 in, and I'd get another 1. And that equals 3. Well, if you notice, that was what this number was. The same thing was here. Well, what if instead I change it to be a 4? And that would mean you have 1 plus 1 plus 1 plus 1, which would equal 4. And of course, that number is exactly the same as that. Right? If I said 5 or 6 or 100, you would expect that, hey, if this was 100, that means I'm adding up 101, so this answer would be 100. And that's just a pretty easy one. The other tool, for right now, you're just going to have to kind of trust me as to why it works, but I promise you it does. We can even test a couple of them just to see that it happens. Let's try 4. Okay? So what we're saying is that this should equal 1 half times 4 squared plus 1 half times 4. So let's just see what it should equal. 16 divided by 2 is 8. 4 divided by 2 is 2, so that makes this 10. Well, let's just see. That would mean that if I added 1 plus 2 plus 3 plus 4, it equals 10. Let's just see. That's 7 plus 2 is 9 plus 1 is 10. It works. In fact, basically what these are shortcuts to figure out these summations without actually doing the summation. So if I wanted to say 20, I would just simply have to put 20 here and 20 here. And then 10, it's 400 divided by, so it's 200 plus 10, so that must mean it equals 210. That means if I added 1 plus 2 plus 3 plus 4 plus 5 all the way up through 20, together I should get 210. Pretty neat, isn't it? In fact, the way that those equations were discovered is through patterns and through something that the calculus students are working on right now called Gaussian elimination. Now, you're just going to have to kind of believe me that they do, in fact, work and how they actually came about, but you just saw a couple of examples showing you that they do work. Well, now let's just see how I want you to use them to go in terms of n. So let's think about it. The first thing I want you to remember is from your homework and the quizzes that we've done is the fact that we have learned that this is the same thing as putting the 4 in front. And by doing that, now we can say, oh, that summation of k is right there. So what I'm going to do then is replace that with 1 half n squared plus 1 half n, giving me 2n squared plus 2n. And that's the answer that I was looking for. So let me show you what I mean with this one. That would mean that basically I'm looking at writing this, and I'm not going to write all the details, so hopefully you understand what's going on here. I'm basically going to separate the summations from the constant that's in front, from that coefficient. Now what about 7? Because it also, see, all of them, if you can almost picture this like a distributive sign, what is the summation that should be written here? Did you say 1? I hope so, because that's exactly what that is. Remember, that's like 7 times 1, and so the summation of 1 is what we'd want there. So again, I'm going to replace the summation of k squared with 1/3 n cubed plus 1 half n squared plus 1/6 n. And that whole thing we're going to multiply by 6. Then we have minus 8, and in place of the summation of k, I'm going to put 1 half n squared plus 1 half n plus 7, and in place of the summation of 1, I'm going to put n. And then I'm going to neaten this up simply by doing that multiplication, giving me 2n cubed, 3n squared plus n. Now careful, this is negative 8 throughout, right? So it's negative 4n squared, negative 4n plus 7. And I'm going to combine like terms with the other n. Okay, 3 minus 4, so it's negative n squared. N minus 4, that is negative 3n plus 7. And that is the answer that I'm looking for. Now what that basically says is I could put any number in here, let's say 5, and if I wanted to figure out, rather than plugging in 1 into this equation, 2 into this equation, 3 into the equation, 4 into the equation, 5 into the equation, and adding these terms together, I can literally just put 5 inside here for n, inside that, and get what the summation is without doing all that algebra and then adding together. Pretty fantastic, wouldn't you say? And so what I want you to do in your homework assignment, well, I'd say tomorrow in class, we're going to be working on this kind of substitution where you're basically subbing in place of summation of k squared, summation of k cubed to basically put that all together. And eventually we're going to work on this in